All right, guys, welcome back to another exciting round of chemistry notes. In this video, we're going to talk about significant figures, which, as the name implies, are super, super important because every math problem we do between now and May, every piece of equipment you pick up to measure, it's going to require you to remember the rules we're about to learn about these guys' significant figures. So these are your new best friends. We love them. And before we jump into the notes, I just want to remind you of something that you probably haven't thought about in several years, and those are your place values. So remember, if you have a decimal point, then the space right to the left of it is your ones. To the left of your ones is your tens. To the left of your tens is your hundreds. To the left of hundreds is thousands. You get the idea. And then out to the right from your decimal point, that first space is the tenths with a TH. The next space is the hundredths. The next is the thousandths. And so on. Remember, there is no one-ths place. And the reason we're talking about this is because significant figures are going to require you to kind of remember this, to talk about the tenths place versus the hundredths place. We're going to use that vocabulary a lot in these notes. So I need you to remember what that looks like. Now that we have done that, let's go ahead and jump in. So the first thing we're going to talk about is measuring with significant figures. Significant figures, heretofore known as SigFigs, because why use all the extra syllables if you don't need them? So SigFigs in a measurement consist of all of the digits known with certainty plus one final digit, which is estimated. What that means in actual usage is, let's say you have a beaker here, and it's sort of hard to see the markings here, but this is the 20 milliliter mark right here. So first of all, do not measure in a beaker. They are not reliable. This is a terrible example. We're just going with it. We're looking at this beaker here, and we're trying to figure out exactly how much water is in the beaker. We're going to go through and fill in all of the things that we know for sure, and then we're going to go one more space. So let's start with the hundredths place. We can see right here that this beaker holds a maximum of 50 milliliters. So there are definitely fewer than 100 milliliters in this beaker. So as far as what to put in the hundreds place, it has to be 0. It cannot be a number because we don't have 100 milliliters. Looking at our next space, the tens space, looking at our water level here, we can see, we don't know exactly where it is, but we can see that it's somewhere between 20 and 30. And if it's between 20 and 30, it's got to have a 2 in the tens place, right? It's going to be 20 something. We don't know what the something is. There are no tick marks between 20 and 30 to tell us exactly what this level is. We can guess, we can estimate it, but we don't know for absolutely certain. So this is everything we know for sure, and then we can just estimate the last one. Looks like we're not quite to halfway between 20 and 30. No, we can say halfway. Let's say we're about halfway between 20 and 30. Call it 25. This number is an approximation. And since this number is an approximation, we have gone as far as we can go. We're not allowed to approximate again. We cannot say anything about the tenths place or the hundredths place or the thousandths place. We cannot say that they're, I think they're 25.6 milliliters in here. We cannot do that because this was already a guess, so we can't guess again. Can't call it that. Best we can do is 25. Or you could say 22 milliliters or you could say 28 milliliters. That last digit in the ones place is really up to you. It's what your eye thinks is there. It's an approximation. So I'm going to say for my purposes that this is 25 milliliters in this beaker. I know the 2 for absolute certain, and the 5 is an approximation. So this is why we don't use beakers to measure things, because all we know for certain is it's somewhere in the 20s. If we were to use something like a graduated cylinder, and I apologize for the blurry picture, we could see a little more specifically. So here we've got a 10 marking. This should be 20, it's a little hard to read, and 30. And then each tick mark in between them is 1 milliliter. So now going back through our same steps, we still know for sure it's less than 100. So this is still a 0. And we can still see that we're between 20 and 30. So our tens place is still going to be a 2. But now we have ones markings. So we can go look at our ones markings. It's definitely past 1, definitely past 2, definitely past 3, and it looks like, since we're measuring from the meniscus, which is the bottom of this curve right here, looks like maybe we didn't quite get to 24. So we can say that's 23. And again, that is something I'm saying for certain, because I can see that it crossed past the 3 and did not reach the 4. So I know this. This is for sure. And since I know this for certain, I'm now going to go one more digit and approximate it. I look like I really almost got to 24. Not quite. Real high, maybe 23.9. And again, you could have called that 23.7. You could have called it 23.8. What you could not have called it is 23.92, because again, this was an approximation. So once you have made one estimate, you cannot go any farther. You got to stop at the tenths place. So what this looks like just in general, any number, when you are measuring with SigFigs, your answer will be every digit that you know for certain, and then one that you have estimated. The last digit in any number is an estimation. So your rule of thumb, the one to sort of record into your brain, is measure everything you know plus one more. Look at every tick mark you are given, record everything you know for sure, and then add one more on at the end. That's an approximation. Let's look at some examples of this. This is a much better picture, a lot easier to see. We've got another graduated cylinder here. We've got a 3 mil mark down here, 4 mils, 5 mils, and 6 up here. So if we look at our meniscus, looks like it's falling right about there. First, let's just figure out where our tick marks are. So these big lines are the ones, because it goes 3, 4, 5 is counting up by ones. These tick marks in the middle break it up even smaller. These tick marks go to the tenths place. So we've got the ones place and a decimal and then the tenths place. And these tick marks are showing us this space right here. So we're going to know this space for sure, which means that we are going to approximate one more space at the very end. We are going to measure to the hundredths place. We know the tenths for sure, so go one more. Now let's go ahead and actually measure it. We know for absolute positive that the ones place is a 4, because we've gone past 4, but we haven't reached 5. So it's going to be 4 point something. And then looking even closer, we know for sure we have passed 0.5, which is this big line here, but we have not reached 0.6. So we know for absolute certain that the tenths place is going to be a 5. And then this space here is going to be the approximation. We don't have a hundredths tick mark, so we're going to guess. I think it looks like we went a little more than halfway, so maybe 0.56. You could have said 4.56. 4.58, or you could have said 4.54. As long as you're ending up in that same hundredths place, it doesn't matter what this last digit is. If it's 4.5 something, then you're good. Let's look at one more together, and then y'all will have some practice on your own. All right, so here we are measuring a nail with a meter stick. And here we are measuring in centimeters here. So these are ones, these big tick marks. And then again, we're splitting it up into even smaller spaces. So those markings, once again, are to the tenths place. So we're gonna know our ones for certain. We can see it right here. Throw in your decimal point. We're gonna know our tenths for certain. We can see them up here. There is not a hundredths tick mark. We don't see that, so the hundredths place is going to be what we approximate. So filling this in here, looks like our nail comes down, oops, hard to draw a straight line, pretty much like that. Might have curved it a little, but I think it's all right. So our ones place, reading from over here, we can see that we crossed 3, but didn't get to 4. So the ones place should be a 3. Then looking at our tenths place, we crossed 0.5, 0.6, 0.7, but didn't quite get to 0.8. So since we passed 0.7 and didn't get to 0.8, this is going to be 0.7 something. Again, I think it kind of looks like we made it halfway, so I'm going to call it 3.75 centimeters. But if you think it made it more than halfway, you could call it 3.78 centimeters. Or if you think it barely made it, you could call it 3.72 centimeters. As long as you have 3.7 something, you have the right answer. You just don't want to go any farther, because if I said 3.753, then what this is telling you is that I know these for certain. I have told you now I can see the hundredths marking on this centimeter stick, and I know it for sure, so I'm approximating one more. This is a lie. I'm telling you I can be more specific than I actually can be. So make sure that you're doing everything you know and then one more. All right, at this point, there's a little bit of practice in your book. Remember, practice makes perfect. So go ahead, pause the video, work through that practice, and when you're ready to check your answers, hit play. All right, hopefully this is what you got on those problems. Again, for the first one, I put 2.3, but since that last space is an approximation, you could have said 2.1 or 2.6. As long as it's 2 point something centimeters, always remember your units, you're gonna be fine. And in number 2 with the graduated cylinder, again, that last space is an approximation. I thought it looked like it went exactly to the mark, so I said 43.0. If you think it went a little bit farther, you could have said 43.2 or 43.1. That's fine too. The last space could be different between our answers because it's an estimate. So that's how you determine significant figures using lab equipment, using an actual device. You're also going to need to know how to find SigFigs just given a number. So the rules here can be a little bit tricky. Why don't you take a second, check out this table, and see if you can determine a couple of things. Pay really close attention to numbers that look similar but have different numbers of SigFigs, or look kind of different, like right here. We've got 408 and 0408, but they both have 3 SigFigs. And down here, we've got, or up here, we've got 2030 point and just 2030, which are the same number, but they have different numbers of SigFigs. So look through this for a second, read it over, see if you can figure out a couple of rules, and when you're ready to look at it, go ahead and unpause the video and we'll talk about the rules. All right, let's see how we did. Rules for determining SigFigs. When you have a non-zero, that's something 1 through 9, any digit that's not a 0, it is always going to be significant. Always. If you're looking at your sandwich zeros, remember sandwiches, you squish things between 2 pieces of bread. Your sandwich zeros are zeros that are between non-zeros. Those always count. They're always significant. Your leading zeros, which are to the left of all of the non-zeros out front of the number, those are never significant. And your trailing zeros, those are the ones out to the right of all the non-zeros, those are the only ones that are a little iffy. They can change depending on your number. So these will only be significant if the decimal point is present. So let's go back and look at some of those numbers we just saw. I asked you to look especially at this top right set of numbers, 2030 point and just 2030. And now we can see why, even though they're the same value, they've got different SigFigs. Here, we have a decimal point. Since we have a decimal point, all of our trailing zeros, namely this one, are significant. So we've got non-zero, sandwich zero, non-zero, trailing zero with a decimal point. That's 40. That's 4 SigFigs. Down here, we've got non-zero, sandwich zero, non-zero, but then this trailing zero without a decimal point. If there's no decimal point, it's not significant. So that's going to give us 3 SigFigs. Looking forward at some examples we haven't seen yet. Number 1 here has 3.0800 milliliters. So let's just go through one at a time. 3 is a non-zero, always significant. This zero is between our two non-zeros. It's a sandwich zero, it is always significant. Here we have an 8. It's a non-zero, it's always significant. And now we have some trailing zeros, but we do have a decimal point. If we've got a decimal point, then these are significant. So that means that here we have 5 SigFigs. Looking at our next one, we've got some leading zeros here. These are leading because they're out to the left, so these never ever count. Then we have 4 non-zero, that counts. We have 1 non-zero, that counts. And we have 8 non-zero, that counts. So we have 3 SigFigs. And last but not least, there are a lot of digits in this third number here, but all of these zeros are leading zeros, which means they do not count. They will never count. We could put 100 zeros out front and none of them would count. Instead, we have this 4, non-zero, so it counts. And we have this 0, which is trailing. Remember that trailing zeros are the only ones that might count and might not. But since we have a decimal point here, yes, this counts, and we have 2 SigFigs. One rule to sort of help you remember this, because it can get a little odd sort of counting through everything, all of your SigFigs will always be in a row. You're never going to count through and say, oh, yes, yes, no, this one is not significant, but these 2 are. You'll never go through like that. They'll either all be in a row or they won't be significant. Also, I understand that some people do a little bit better with tips and tricks than just a list of rules. If that is you, I have something for you. So I'm going to draw a beautiful picture now. Please enjoy it. See if you can figure out what it is before I tell you. These extra lines are going to add some difficulty. Makes it an even more fun game. I'm going to say the only reason this is not identifiable is because of the extra lines, because clearly this is the United States of America. And on either side of the USA, we have 2 oceans. Over on the left, we have the Pacific. Not the specific, but the Pacific Ocean. And over on the right, we have the Atlantic. Pacific starts with a P. Do you know what else starts with P? Present. Over on the right, we have Atlantic, which starts with A. Do you know what else starts with A? Absent. So another way you can look at counting your SigFigs is just determine whether the decimal point is present or absent and start counting from the appropriate side. So if there is, yes, a decimal point, start counting from over here. Don't count your leading zeros and just go until you run out. If the decimal point is absent, then you're going to start counting from the right, and you're not going to count any of the first zeros you encounter. But once you start counting SigFigs, you won't stop until you run out of digits. So let's go back, look at our examples, and put this into practice a little bit. Remember, we've got our beautiful drawing of the country here. I'm a good American. We've got present over here, absent over here. So in problem number 1, the decimal point is present. So we're going to start from this side and we're going to count SigFigs. I'm going to start right here. 1, 2, 3, 4, 5. Because once you start counting, you do not stop counting. So that's 5 SigFigs, which is what we said. Let's look at our next one. The decimal point is present, so we will start on the left. We will not count any leading zeros, so we're still going to skip these because you don't count your leading zeros ever. And then we'll start counting right here, and once we've started counting, we won't stop. So 1, 2, 3 SigFigs. And last but not least, decimal point is present, so we'll start from the left. Still won't count those leading zeros. 4 is the first digit we will count, and we will keep counting until we run out. So 1, 2 SigFigs. All right, so now you've got a little bit of practice in your book. Go ahead and go through, try and figure out how many SigFigs each number has. If you want to just use your list of rules, do that. If you want to use your USA, do that. If you found another pattern, that is awesome. Please share it, and just go ahead and feel free to use that. So take a minute, pause the video. When you're ready to check your answers, hit play. Hopefully this is what you got for that practice. If it's not, then hopefully you can at least see where you went wrong in your counting. If you thought you had it and you felt good and you checked your answers and they are not correct, definitely come see me or some other teacher ASAP so we can go over it. Because the sooner you learn SigFigs, the easier your life is going to be. You'll be able to just start implementing them into your math without even thinking about it. Because that's the next step. Now that we have learned to count SigFigs and measure with SigFigs, we are going to learn how to do math with SigFigs. That's going to be the last thing we learn in this video, is how to math with them. As we are doing this, there are going to be 3 rules to memorize. Know them, love them, they're your new best friends. Look at how happy this guy is. He's so excited that he's learning SigFig rules because he knows that it's going to make him a better chemist. Are you ready? Here we go. Rule number 1. When adding, that's the plus sign, or subtracting, the answer must have the same number of decimal places as the measurement with the fewest decimal places. So now that we've spent all of this time counting SigFigs, the first rule we're going to talk about doesn't need you to know how many SigFigs there are. You just need to know which digits are significant. What does this mean? Let's take a look. All right, so here's an example. We have 2.345 plus 0.07 plus 2.997. So we're going to add these all together. Feel free to just punch this into your calculator. And when you do that, you should get 5.4125. But we have said that our answer should have the same decimal places as the measurement with the fewest decimal places. So here, our first measurement goes to the thousandths place. It has 3 decimal places. Our second measurement goes to the hundredths place. It has 2 decimal places. And our third one has 4 decimal places. So the smallest one is this one right here, which means our answer can only go to the hundredths place. So we're going to cut this all off, round if we need to, and we're going to end up calling this 5.41. Because again, our measurement with the fewest number of decimal places should equal the fewest decimal places in our answer. Hundredths place, hundredths place. Let's take a look at another one. Number 2 here, we are doing subtraction. We have 5.9 minus 0.221. So again, plugging this into our calculator, it's going to tell us 5.679. But once again, we have to consider our rounding. And your calculator doesn't care about SigFigs. So this is going to be something that's going to be a struggle probably all year. You're going to work a problem. When we get into those more complex units, you're going to do a lot of math and you're going to get to the end and you're going to be so excited that you have your answer. Here's what my calculator told me. Let me write it down. You need to be smarter than your calculator. You have to take the number it gives you and then round it appropriately so you get all of your full SigFig points. Because here, our 5.9 goes to the tenths place and our 0.221 goes to the thousandths place. This is the fewest number of decimal places, so we can only go to the tenths place. We need to cut this off and round it. This 7 is going to tell us to round this up. So this will become 5.7. 5.6 rounds up to 5.7. So that's going to be our answer to number 2. Looking at just one more here, we have 1010 minus 15.2. So once again, putting this into our calculator, we're going to get 994.8. This one's going to be a little bit different than the other 2 examples, but it's really important and something people tend to kind of forget. Because here, 15.2 goes to the tenths place. Easy, it's got 1 decimal place. There is no decimal point here. Also, as we now know, this 0 is not significant. It's a trailing 0 when the decimal point is absent. This 0 doesn't count for SigFigs, and if it doesn't count for SigFigs, it doesn't count for place value. So actually, the fewest number of decimal places would be the tens place. This is sort of our least specific significant figure. So we're going to have to round this to the tens place. So that means that we're going to cut it off behind here. This 4 says to round down. So for our answer here, we're going to put 990 as our answer. That one's a little weird, but don't worry, you're going to have time to practice it. Before that though, let's look at rule number 2. This one's a lot more straightforward. Rule number 2 says that when multiplying or dividing, the answer can have no more SigFigs than are in the measurement with the fewest total number of SigFigs. So that whole decimal place, where are the SigFigs in the number, doesn't apply. Just count up your total number and go from there. So looking at example number 1 here, we have 1.052 times 12.504 times 0.53. Plugging this into our calculator, we are going to get 6.97173 ... It goes on forever. But we can't write this whole number down. This is not correct. If we look back at our measurements, this first one here, let's count up our SigFigs. This is a non-zero. This is a sandwich 0, non-zero, and non-zero. So here we have 4 significant figures. On to our next one, non-zero, 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 sandwich 0, non-zero. These are all significant. Here we have 5 SigFigs. And last but not least, we have a leading 0. This does not ever count. And 2 non-zeros. So there we have 2 SigFigs. This is the measurement with the fewest total SigFigs, and it has 2 of them. So our answer is going to have 2 SigFigs. So we're going to have to cut it off behind this 9. And this 7 tells us to round the 9 up, which gets a little weird, but 6.9 actually rounds up to 7. So that's the answer you would put here is 7.0. It has the same 2 SigFigs that our smallest measurement had. So again, a little more straightforward than your adding subtracting rules. Let's look at another example here. Says number 1 again. This is obviously example number 2. This time we are dividing. So we have 2.0035 divided by 3.20. When you plug that into your calculator, it's going to tell you 0.6260937 other stuff. And again, this whole number is not our correct answer. If you put this whole long number down on the test, sure, it's what your calculator gave you. Sure, you probably did all the right math, but you're still going to lose points because you didn't use the correct significant figures. So let's go back and look at our measurements here. We have a 2, that's significant. A couple of sandwich zeros, those are significant. A couple more non-zeros, those are all significant. So we have 5 SigFigs in this number. Over on the right-hand side, non-zero, non-zero, trailing 0, these are the questionable ones, but we do have a decimal point, so it is significant. So here we've got 3 SigFigs. 3 is smaller, so we're going to go with that one. We're going to have to round this answer to 3 SigFigs. So we're going to cut it off behind the 6. This 0 says to round down, so we will get 0.626 as an answer. All right, one more rule, and then we're going to get a chance to practice this. Rule number 3 is kind of a long one. Basically, it says when you don't need to worry about SigFigs. And that is for counted numbers. So this will come up a little bit later, but if I say something like, there are 26 people in this class, I went through and counted each person and came up with 26. So that number, if I use it in a calculation, will not affect my SigFigs. Again, we'll see examples of this later in the year. Our next blanks are conversion factors. We will learn about those in just a few lessons. Probably didn't need a blank that big. And constants. So we're going to use a lot of constants this year, like Avogadro's number and the speed of light. And those are mathematically, scientifically determined. They are just facts of life, and they are rounded already. So we're not going to use those for SigFigs either. So counted numbers, conversion factors, and constants, we're just kind of going to ignore when we're doing calculations. One last thing before we get into our last round. PEMDAS, it's still a thing. Your order of operations are still important, and they're going to affect your SigFigs. You're going to have to do these in steps. This is no longer just let me just plug everything into the calculator, see what happens, because that's going to give you the wrong SigFigs. So let's look at an example of this. We have 6.78 times 5.903 times 5.489 minus 5.01. So remembering our order of operations, we're going to do the math in those parentheses before we do anything else. So we're going to do 5.489 minus 5.01. That's going to give us a value of 0.479. And this is what your calculator will spit out for you. Is this reported to the correct number of significant figures? If you look back up here, we're doing subtraction, so that's the decimal place. Where are they kind of rule. Here we go to the thousandths. Here we go to the hundredths. Our answer should really be rounded to right here. Here's the weird part though. You don't want to round in the middle of the problem. So you're just going to mark where you would have rounded to if you were going to round it. It's weird. It's a little confusing. You will get the hang of it, I promise. So we're going to write down our results of this math, and we are going to say, I know I should have called this 2 SigFigs here. I really should have rounded it, but I'm going to leave my full answer so it doesn't mess up my final. So now I'm going to do the rest of the problem, and I'll do 6.78 times 5.903 times this number here, the whole number. I'm going to type in the whole 0.479. And when I put that in my calculator, I'm going to get 19.17070 ... It keeps going forever. This is the number I get at my end. But now again, I'm really going to round this time because this is really my final answer. So this time I did multiplication. Those are total number of significant figures rules. Here we've got 3 SigFigs. Here we've got 4. And here, remember, we were going to round to just this. So that would have been 2. And since 2 is our smallest number, we are also going to round our answer to 2. We're going to go 1, 9, and then just cut it off. Remember to always round. One says to round down, so that's fine. We would get a final answer of 19. And that's why it's really important to do this in stages, because if you had just plugged this all into your calculator and gone back and rounded later, you would have said, well, this had 3 SigFigs, and this had 4, and this had 4, and this had 3, so I guess I should round to 3. But that's not what actually should have happened. So when you are doing multiple steps of calculation, make sure to split them up so that you do your rounding correctly, because this is not what you want to be doing. This is bad. All right, at this point, you've got a little time to practice on your own. If you want to go back, look over each one of the rules one more time before you dive in, that's probably not a bad choice, because at this point, you should go ahead, pause the video, go ahead and work through those examples, and when you're ready to check your work, unpause and see if you got the right answers. All right, hopefully this is what you got. If it isn't, you can go ahead, head over to my website. I've posted a key that has more specific work shown for each of these answers. And if you're still confused about how to count SigFigs, how to measure with them, how to use them in calculations, there is more practice at the bottom of this page that might help you work through it, or as always, come into tutorials to me, to any other teacher, and we'll get you straightened out. But again, this is one of those super important skills that you want to get under your belt as soon as possible. So the sooner you can come in and get this fixed, the better you will be. So good luck, do your practice, do your quest, and happy studying.